Marching squares is a versatile algorithm used in procedural terrain generation, physics simulations, and more. It enables the visualization of noise contours, making it possible to create features such as caves. Here you can see a lot of spheres, and each of them has different color based on a noise which I have created. And you can see that in the parts where it is black, so the value of the noise is 0, there is just empty space. And in the places where these dots are white, there is some kind of terrain using the marching cubes algorithm. Why is it called marching cubes? Because it just loops through the grid where I want to add the terrain, and it just adds many configurations of cubes based on the noise value, so you can see that it is gradually transitioning from one point to another based on the noise. Because we are in 2D, each of these squares has just 4 vertices, which is composed out of 2 triangles. Each of the vertices of the square can be either turned on or off. In total, this gives us 2 to the power of 4 configurations that we can have of the square, so this is 16 configurations. Down here you can see all of them, so when none of these are active, we are just not drawing anything. When just the top left vertex is active, we'll just draw a triangle. The same way for the second configuration. With the third one, we have those 2 top vertices activated, so we are drawing a rectangle, and so on. So here you can see all of the different configurations. So how I came up with them, because we have 4 vertices, and each one of them can be just on or off, we can easily store this value using 4 bits. So let's say that this vertex is on the first bit, so it has value of 1, this one has value of 2, 4, and 8. Using this knowledge, we can easily construct all of these different variations of the square. So when it is 0, it is just like that. Then when it is 1, we want to turn on the vertex in the top left corner, because here the binary value is 1. Then when we want it to be 2, it is obviously in the top right corner, where it is 2. And if we want to have 3, it is just combination of 1 and 2. If we want to have 4, it is 4. When 5, it is combination of 4, 1, and so on. So like this, you could draw all of these individual configurations by yourself. And then, as we'll have the noise, which will also be constructed of individual dots, just like you can see here, we'll have some threshold value, which will just tell us if we can see it or not. So the noise value will be anywhere between 0 to 1, but let's say that only if it is less than 0.5, we want to be able to see it. So all points that will have value of the noise less than 0.5, we'll just turn them to on. So we will draw some of these configurations based on how many vertices we turn on. And this is all for the theory of understanding marching squares. If you don't understand it yet, don't worry, I will show it to you step by step. So we'll go to Unity and I will create new C# script. I will put the script on some object in my scene, so I have created just empty object for the marching squares. And under this object I have also created another empty object, which will be just holding all of these circles that we'll generate, which will just help us to visualize the noise. To generate the noise, we'll need to know how big it will be, what will be the resolution of the noise, and have some 2-dimensional array, which will be just storing all of the values of the noise based on the x and y coordinates. We have a variable for the size, noise resolution, and 2-dimensional float array containing all of the heights values, which you'll take from the noise. If you don't know how to create 2-dimensional float array, it is pretty simple. Just type comma into the square brackets, and now I will create new void in which we'll set all of the heights to the array based on the noise. First, we'll need to initialize the heights array. So if we want the size to be, let's say, 2 squares width, we don't only need to have 2 height values, but 3, because there is 3 vertices. So size of the array will be just size plus 1. Then we'll add 2 for loops, looping through all of the x and y coordinates based on the size that we want our grid to be, and we'll just assign some value to the heights in the float array. So we are going through all of the x and y coordinates until it is less or equal to the size. Don't forget to have the equal here, because we are creating the array with the size of size plus 1. And then we just assign value to the heights on the index of x and y using the Visualizing Noise, which just generates a noise with values gradually transitioning from white to black, so from 0 to 1. And we can just multiply the positions that we are inputting into the parent noise by the noise resolution. Now, as we have set all of the heights in the array that we need, we can actually visualize it and see how it will look. So I will create variable for some kind of circle parent, which will be parent of all of these circles that we are going to visualize the noise with. Then we'll need a prefab for the circle so that we can just spawn it in. And then in some function we'll first destroy all of these circles if there are any, and then we'll spawn them. So we have a transform variable for the circle parent. Then for the circle prefab, I've also created the void to create the grid, which I'm calling in the start. In this void, in the beginning, we are looping through all of the children of the circle parent and destroying all of its children, if there are any. And then we'll again loop through all of the x and y coordinates and assign some position to the new instance of the circle that we'll create, assign some color, correct size, and to have a bit more control over how it looks overall, I will add another variable for the resolution, so that we can independently control resolution of the noise and resolution of the whole grid. And it is that simple. We have 2 for loops that are going till the x is less or equal to the size, again because we have created the heights array with the size plus 1. Then I'm defining a position using the transform.transform point to make sure that the position is converted to the local space of the parent where we are creating all of the circles. And then I'm just inputting the x multiplied by the resolution and the y multiplied by the resolution. Then I'm creating transform for the new circle, which I'm just instantiating from the circle prefab at the correct position and at under the circle parent. And lastly, I am getting the sprite render from the new circle so that I can assign it new color, which is just the heights value because it is from 0 to 1. So we can just take the heights value on the x and y coordinates and input it to all channels so that the color is from white to black. Now we can go to Unity, assign all of the values and create a simple prefab for the circle. So just create 2D object, sprite, circle, put it somewhere to the project. Now we can delete it and just put all of these variables here. Cool, now we can see visualization of the noise. We are obviously not able to edit it all at runtime, which is the next thing that we'll do. To make sure that it is not constantly updating in update, I will just make it update every couple of seconds or milliseconds by creating new coroutine. So I have created new coroutine, which I'm calling in start. And I have just a simple while, which is basically running all the time because the condition is just set to true. And then I'm just calling all of the functions that we need and waiting for some time so that we always call these 2 functions, wait for some time, call them again, and so on. So now we are able to adjust the size at runtime, the noise resolution, and also the resolution, for which I forgot to set size of the circles, so I will just quickly do that. To get the correct scale of the circle, we can just do vector2.1 multiplied by resolution, and I like to divide it by 2 so that the circle is not too big. Yep, this seems to be working well. And after we are done with visualizing the noise, we can get to the more interesting part, which is creating the mesh. To make sure that this object is containing mesh filter and mesh renderer, which are 2 components that we need on an object to have to render, I will add attribute to this whole class which is require component type of, and I will add the mesh filter and mesh renderer. Yep, and when we play the game, we can see that those two components got automatically added. Next, I will create variable for the mesh filter so that we can get it in the start, and later assign the mesh of the mesh filter. I will also create variable for all of the vertices, triangle indexes, and new function in which we will create the mesh, assign the vertices, and so on. We have a variable for the mesh filter, which I am getting in the start. Then we have a vector-free list. It is a list because in the array you need to specify the size, which we are not sure about how big the array is going to be. So it is a list of vector-frees for all of the vertices that the mesh will have, and then a list of all of the integers. Down here I created new function, createMesh, which I am also calling in the coroutine. And I'm just creating new mesh, I'm assigning vertices, and because the vertices are stored in a list, we need to use vertices.toArray, the same thing with the triangles, and lastly I'm assigning the mesh to the mesh filter. And now we can actually get to marching the squares, so I will create a function for that, in which I will go through all of the coordinates in the grid, and later we'll also need to get the corresponding height values from the height array. Pretty simple, we are going through all of the x and y coordinates based on the size, but here it is when x is less than size, because as I said, when we have two squares, there are three vertices, but still two squares. And then we are going to want to get all of the bits representing if each of the vertices of the square is turned on or off. And this we'll get from the heights array. Float A can be just the vertex on which we are trying to build the square or march it. So just to show you in the paint, it will be this one, because we are trying to build the square based on this vertex. And if you remember, this is on the last bit, so it has value of 8 if there is one. This is pretty simple. Then we'll have the B, and we want to be going in order from the biggest bit to the smallest one. So we want to go one to the right, because right now we are on this one, which has the value of 8, and the vertex next to it has value of 4, so we want to go there. We can just add 1 to the x coordinate, just like that. Next, we want to go to the C, which is up here, which has value of 2 if there is one. So we'll need to do x plus 1 and y plus 1, like that. And to get the D, which is the last one with the lowest value, we'll just need to do x and y plus 1. Right now, all of these values are floats, so they can be anything from 0 to 1, and we want them to be only 0 or 1. So I will create variable for the threshold, which will just help us to decide if the value should be 0 or 1, and then I will create function which will just return the correct value. So when it is less than 0.5, it will be 0, and the other way around. And now I will just create simple function, which will return us integer 0 or 1. Into this function, we can input any value, and if the value is less than the height threshold, it will output us 0, otherwise it will give us 1. Right now there is no way for us to use it, so we'll also need to create new function, which will be used to march just a single square, which will be taking in all of the 4 bits, so either 0, 0, 0, 0, 1, 1, 1, 1, and so on. And now we can combine it all together. So when we are marching all of these squares, after end of the for loop, we can call the march square, which will march just one square, and we'll need to input all of the integer values, so we can use the function getHeight, into which we'll input all of these float values. In the march square void, now we'll have all of the correct values representing zeros and ones, so we can just calculate it into one single value. Just like that. If you are still remembering, the A is the last bit, which has the value of 8, then the B, which has a value of 4, C of 2, and D of 1. So this is how we calculate the AND value, by which we are going to decide which of the configurations of the square we are going to draw. So I will create new switch statement, and we are going to switch between all of the different configurations from 0 to 15. Like this, we would do it for all of the different configurations, but I will first write some code for the first one, because then it will be pretty much the same. For the case 0, we can just return, because if you remember correctly, when there are no active vertices, we are not drawing anything, so we don't even need to go into the switch. And what will we be doing in these different cases? We'll just be setting vertices to some vertex array and indexes of the triangles. But I'm not gonna be setting it to the array containing all of the vertices. I will create a new one in this function so that we can later do some more calculations with the vertices and indexes. So we have vector-free array for all of the vertices and integer array for all of the triangles. Sizes of the arrays pretty much doesn't matter because we'll be initializing them in the individual cases. So this is how the basic structure of the switch is going to look. Now, at what positions and indexes we should set these two arrays? Well, we can just decide how we want it to look. So let's take a look at the case 1. How many vertices are there? There are just 3. We have one here, and one here. And now we can just decide where we are going to start and input all of the positions. So I will start in the middle here, which the x is on 0 and the y is on 0.5. For the second vertex, I like to go clockwise, so then it is 0 on the x and 1 on the y. And the last one is 0.5 on the x and 1 on the y. Now with the triangle indexes, it is important that you go clockwise, so we can just go 0, 1 and 2. So I will write it here, 0, 1 and 2. It is that simple. And like this, you could write it for all of these configurations, but I will also leave you a link for this whole code in the description, so you can just copy this part with these different configurations. With all of the configurations, the switch statement should look like this. It is pretty long, but wait till you get to marching cubes, because the tables here are a lot longer than this. And now we are pretty much at the end. We only want to offset all of these vertices by some amount. So I will just add two new parameters to this void, which will be the offset x and offset y. And we can just input them in these for loops when we are calling the void marked square. I will just input the x and y values from these loops. At the end of the void marked square, I will loop through all of the vertices that we added to the vertex array and just add the correct offset to them and multiply it by the resolution. We are going through all of the vertices, and to the new vert value, I'm assigning the old vertex value plus the offset multiplied by the resolution. And then we can just add the new vertex to list of all of the vertices. And we also need to do something with the triangle indexes, because right now the indexes are still the same. They are 0, 1, 2, but obviously as there are more vertices, we'll need to be also increasing the triangle indexes. For that, before the switch, we'll need to get length of the vertex list. So we are getting count of the vertices, and then after the switch loop, we'll again go through all of the triangle indexes and we'll just add the amount of the vertices to them. And it is that simple. We are going through all of the triangle indexes, adding them to the list with all of the triangles, and the correct value is just the triangle plus the count of the vertices. Whew, this was a lot of code for one video. We have over 200 lines of code, but it should be working. So let's take a look into Unity, assign some material so that it is not just pink, and we'll see. And voila! Here we can see the grid with all of these circles, which we have done before, but at the parts where the value is closer to 1, we can also see some of these squares getting generated. So I will just turn off the noise visualization because we don't really need that, and we can play with the values. So we can make it bigger, make the resolution smaller, and we can see one mistake that I made. So I just forgot to clear all of the lists, which could lag your PC pretty badly. So we'll go back to the code, and when we are marching these squares, which is somewhere over here, we'll just need to clear the vertices list and triangle list, just like that. So test number 2, we can increase the size, decrease the resolution to have a lot more detail, and we can play around with the height threshold. So as I'm lowering the value, there is a lot less space, and as I make it greater, there is air pretty much everywhere. We can also play around with the noise resolution to make the holes bigger or smaller, which you can see is working pretty well. You will just have to fine-tune all of these values, and it looks pretty nice. You can see that all of these walls are pretty smooth, even though we could make it a lot smoother by using some linear interpolation, which I will leave for other tutorials. Right now it is also kind of laggy, so to make it more performant, we could use compute shaders, but this is also a topic for another video. So now you should have better understanding of marching squares, and you can use them to create some pretty amazing results, such as caves, and some procedurally generated terrain. And in the next tutorial, we will take a look at something a bit more harder, which is 3D version of this algorithm, marching cubes. I hope that this video was useful. Don't forget to like, subscribe, and I will see you in next videos. Bye! Thanks for watching this video till the end. If you are looking for a Unity, C# or Bolt tutor, then I am here for you, so feel free to send me a message to my Gmail and take a look at my website for more info. I can help you with your personal projects or teach you anything about game development you would want to know. You are welcome.